Could you please briefly introduce yourself, where you're from, where you currently work, and how did you get to the position you are today?
I'm Štěpánka Nedvědová, and I'm from Prague, and I'm currently finishing my first postdoc at the CNRS, which is French Center for Research as an Academy of Sciences in the Czech Republic. The position is a postdoc in structural biology at ICSN, which is Institute of Natural Substances, which is near Paris, 20 kilometers from Paris.
You describe yourself as a protein explorer and a biophysics enthusiast. What first drew you to the molecular world of proteins?
I was always somehow interested by proteins. Other molecules doesn't really appear to me, so I always loved proteins. I started as a food analyst, and afterwards I switched, after my studies, I switched to biochemistry more, and so there I started to work on structural biology, and here the passion for proteins grew up, and now I'm really protein enthusiast, I would say. Doesn't matter what kind of proteins I work with, I love them all.
How did your scientific path evolve from studying in Czechia to now researching in France, and what motivated you to take that leap abroad?
So I've done my bachelor studies at the Czech University of Life Sciences in Prague. And after my bachelor studies, my dad went to work in France, near Aix-en-Provence. And he told me that everything is very nice there, so we went with my mom to visit him. We've spent a month there visiting all amazing places there. Afterwards, I decided to go to do some Erasmus after my first year of master studies. And I chose Avignon, which is in the same region. And afterwards, I finished my master studies in Prague, and I started to do postdoctoral studies. Then came the offer or proposition to do co-tutel in Barrand Fellowship. So I applied for this fellowship. I got this fellowship, and I went to do this co-tutel between, again, Czech University of Life Sciences and University in Lyon. I thought that I was done with France, but finally I returned here after my defense to work with one of my jury of the defense in Paris. Now,
you're a postdoctoral researcher at the CNRS. What exactly is the institution that you work in, and what are its main missions?
So the institute is within the chemistry part of CNRS, and it's Institut de Sciences Naturelles, Institute of Natural Substances. And it's a very nice institute. It was one of the most famous one in CNRS because there was a guy called Pierre Potier, and he invented or found the way to semi-synthetize Taxol, which is an anti-cancerous drug. And so this brought a lot of money to our institute, and also that's why somehow I'm there, because the institute bought a really amazing equipment. Until this day, even if Taxol is already generic, we still have amazing equipment. And so the institute is divided into 4 different departments, and main building is filled with organic chemists. And our building, smaller one, is filled with amazing equipment, but also with structural biology and some interface between toxicology and ecology and biology, so we are more interdisciplinary team.
Now, concerning your research particularly, what does it focus on, and how would you explain to a non-professional what it is that you are studying and researching?
I'm working on respiratory syncytial virus, which is a virus which is deadly, killing a lot of people every year. And unfortunately, till now, we don't have any antiviral therapeutics. We have some prophylaxis and some very expensive antibodies from Sanofi, but unfortunately, this is available only, for example, in Europe or rich countries in America, but within the rest of the world, which doesn't have this chance, it's not available. So I'm working on different proteins within the RSV genome. And mostly we are focusing on RNA-dependent RNA polymerase, which is let's say, the heart of the virus. It's the machine which is fabricating new viruses. So, for example, for vaccines, the common approach is to target, for example, those spike proteins or something at the surface of the virus. We are really interested in the replication. So we think that if we can block the replication, the virus will not be replicated and the problem is solved. So on the paper, it's straightforward and it's very easy. More specifically, I'm working on the transcriptional factor of one protein, and I'm trying to block this interaction. And I'm also working with one protein, which is called non-structural protein. And here it's a different approach, but we are still trying to block this virus for spreading all over the body and inducing the infection.
So to what extent or in what horizon of time would you say that the research that you're currently doing could have therapeutic, real-life implications for treating viral diseases?
Yeah, this is the tricky one. So we found really nice molecules, but with the drug discovery, the problem is more complex because it's not only the clinical test and so on. That's a nice part, but for really like the first steps of the research, the problem is I have a lot of nice molecules, but how to deliver them, how to solubilize them. For me, it's easy because in the Eppendorf I can mix whatever I want, and once it's soluble, I can do these interactions and see it's working well, it's binding well, it's blocking. Unfortunately, in real life, it's more complicated. So for sure, we will file some patents out from this research, but this in France will take forever. And afterwards, also, this research is not only ours. So at the conferences, I've seen a lot of posters and presentations working on similar approaches. So I would love to tell you it will be in next 5 years. Unfortunately, I don't think so, but I just hope that this work we've done will help to resolve this problem, because it's really an emergent problem and we need to solve it. It's really killing guys, unfortunately. And for example, in infants, it's really important to find some vaccine or way to help this not happen. I would say viral infections are also very disastrous. We are always speaking about antibiotic resistance and so on. I think that next pandemics will be also viral.
Now, you also mentioned earlier some administrative challenges with patenting and accompanying your research. Are there any technical challenges that you face when working with proteins?
Yes, there's a lot of technical problems. Actually, I am always struggling with proteins. There's no, at least in my life and work, I've never worked with protein which would be like, yes, I have the sequence and it's expressed. Never. I heard that it happened to my colleagues, but never to me. Problem with proteins, you need to produce them in a living material. Usually it's bacteria or yeast or even insect cells or mammalian cells. It's difficult to do it correctly, and usually you are the first person expressing this protein, so there's no data about how to do it. So there's the first struggle. Next struggle is you can have it expressed, but you will not be able to purify it. So here you can spend years, and once you have it, it may not be stable. So you need to treat it with very specific kind of condition, and you will have it for a day or a week. But you need to test it for various conditions and so on. So it's difficult, and I can tell you honestly, I spent 4 years of my 5 years PhD just expressing proteins.
Now, looking back at that body of work, what are some of the projects or publications that you are most proud of?
I think that I'm the most proud of my first publication of my work, and it was about proteins of parasites Schistosoma manzoni. And those proteins were really hard to crack. I actually never really succeeded, so I needed to, and it's the title of the paper, Divide and Conquer. And I need to find some solution in order to solve the structure, which I've done. And it's my first paper where I used nuclear magnetic resonance, which is my favorite analytical tool. So I would say this is the publication I'm the most proud. And it was also the publication where I worked the hardest to have it, because I needed to defend my thesis and so on. But I would say different papers are same important. It's just the first one is for me the most important one.
Now, looking forward, what are some of the projects that you look forward to working on in the future, and are you planning to stay in France?
So now I'm finishing my first postdoc here, and I decided to move in some other country because it's easy now here, so I need to move somewhere where it's more difficult. So I plan to go to Germany, and there I will work not so much on structural biology, but I will still work with proteins, but really differently, because it's an institute of new materials. So here I will work more on biophysics and physical characterization of new materials. So I can't wait to start work on it, because I will learn a lot of different techniques. And also I have this collaboration about protein cages, so I hope that in future, and even like not only the future which is right next to the door, I would be happy to collaborate with my colleague, because there's a lot of potential inside this project.
Now, of course, we talked about international environments, but you've also been very active within the Czech scientific community here in France. How strong is the Czech scientific presence here, and what does it mean to you to be a part of it?
Yeah, firstly, I need to say that I'm very proud, and I'm always telling to everybody that I'm Czech, not French, because at all the conferences I have this name tags with CNRS or Paris or Živ-Surivet, and I'm like, no, I'm not French. I'm proud Czech from Prague, and actually this community, I don't know that much about different Czechs working in science here in France. I've met them quite recently at the first Czech meetup at the Czech embassy, and I learned that there's a lot of amazing guys doing really amazing work, and I was so happy to join the organization team, and that's where I became active within this community. And I was so happy how all the organization turned out, because even the organizers are so interesting and amazing guys doing really top-notch science.
Now, just to wrap up, what advice would you give to young scientists from Czechia, particularly women who are considering a research career abroad?
I would say, don't expect that it will be easy, particularly in France, I would say, but do it, because it's the most important path you will do in your career. It will change completely your vision of the world, your approach to the science. You can have a really interesting network within not only one country. And also, if you are going to France, learn French, because if not, you are not going to go very far.
Fantastic. Well, thank you very much.
Thank you.